Okay, continuing on with domain. Happens to be two fractions, but still going to be the same thing. All real numbers, except where x squared plus 7x equals 0 or x minus 6 equals 0. This guy, I can factor out my x. That guy's just going to be 6. It's now factored and equal to 0, so split it up. And so I get all reals except x equal negative 7, 0, and 6. You can write it that way as far as I'm concerned. If we wanted set builder notation, set builder notation would be this: the set of all x such that x does not equal negative 7, 0, and 6. And if we want an interval notation, and I'll start up here with interval notation, negative infinity to negative 7, negative 7 to 0, 0 to 6, 6 to infinity. Not sure what the computer asked for. I think the computer asked for interval notation. Again, we have to have parentheses because parentheses exclude numbers. You'll read whether they want the union symbol or commas. It should be the union symbol, but sometimes they'll say separate by commas. Do whatever it tells you to. For me, I wouldn't care if you gave me union or commas. I just want you to get the idea across that you knew that you can't let that denominator be 0. Okay, next fractional one. So this would be all reals except where x squared plus 4 equals 0. And so I go to solve that. We remember that plus or minus. And then you also have to remember that I said, I don't remember in what video, but I said in one video somewhere that when we're doing things graphical and functions, so graphical ideas and functions, we are not going to use imaginary numbers. Then I also said right here, the domain is a set of all x values that when substituted into the function will yield a real number result. Right here, this is imaginary. There is no place, there is no real number that will cause the denominator to be equal to 0. There's no real number that'll do that. And so, my domain is all real numbers and negative infinity to infinity. So you do have to remember that little thing that when we're talking about functions in this class, it's not that you can't do imaginary numbers and functions in general. You can. But in college algebra, and when you get to calculus 1, 2, 3, survey of calculus, we don't do imaginary numbers, primarily because calculus and imaginary numbers are so much harder than calculus and real numbers. So when we are doing domain, we're talking about real numbers. There is not a real number that's going to give me the except part. It's all reals except I didn't get an answer to the except part. So the domain is just all real numbers. Okay, so we started this domain conversation with 3 facts: polynomials, rational numbers, and square roots. So finishing up with the square roots. Find the domain of each of the following. Domain fact number 3. The domain of a square root function is a set of x values that will result in the argument of the radical, the inside of the radical being greater than or equal to 0. for the reasons that we just discussed. We are not using imaginary numbers. So if I'm not going to use imaginary numbers, the inside can't be negative. And the way you make the inside not be negative is to say that it's greater than or equal to 0. And so here, immediately, the domain is the solution to 8 minus 2x greater than or equal to 0, because we're not using negatives, or we're not using imaginary numbers, so I can't let the inside of my radical, can't let that argument, that radicand, be negative. Well, if you're not going to be negative, that means you're greater than or equal to 0. So solve this guy. And then one of the things we really wanted to talk about in this problem, and if I had a classroom full of students here, which you don't, I'd say, okay, we just divided both sides by negative. What do we have to do? And someone would tell me, flip the inequality. Got flipped. Divided by a negative. And so we get x less than or equal to 4. That's a perfectly good answer for me. You could stop right there. The funky set builder notation, the set of all x, such that x is less than or equal to 4. Interval notation, negative infinity to 4, with a square bracket on the 4. Either one of those will make me happy. Okay, last domain problem. 1 over the square root of x minus 10. So I've got two things going on here. For the square root, I need this. I need the inside, the radicand, the argument, greater than or equal to 0. And without much fuss, that gives me x equal greater than 10. For the fraction and for the fraction, and for, I'm trying to write so you can actually read this. And for the fraction, we need that denominator to not be 0. Fractions, you must exclude any place the denominator can be 0. So I could solve this, square both sides. And so I need to combine x greater than or equal to 10 and not equal to 10. So combining x greater than 10 and x not equal to 10. So combining those two things, doing what's really technically their intersection, gives that I just want x greater than 10. That I pick the numbers that will make both those statements true simultaneously. And so as long as I'm strictly bigger than 10, I satisfy this guy that says invite everyone to the party except, invite everyone to the party greater than or equal to 10. And this guy is over here saying can't stand 10. Well, now 10 might feel a little unhappy and excluded, but everybody else is going to be happy with greater than or equal to 10. That you want the set of numbers that will make both of these sets true. So x greater than 10, which would give me 10 to infinity as my domain. And there's what we have to say about domain. Now the other topic in this section is composition of functions. And so trying to explain what the composition of functions are. So we got the official mathematics first. The composition of the function f with g is denoted by f of g. So that's a little circle, does not mean multiplication. Little circle means composition. and is defined by the equation f of g of x equals f of g of x. They're both read the same way. That is read f of g, f of g. That's how that's read. And then both of these guys, f of g of x and g of f of x, I wrote that in the wrong order. They're both read f of g, drop down a line here, f of g of x. And that little circle stands for composition. And all mathematicians give us for a definition is this. But that's good enough. It shows you what composition is sort of doing, that we're putting one function inside another. That's one way to think of composition, one function going inside another. Then we have some stuff about domain. We just aren't going to deal with the domain. So while it's there for completeness' sake, I'm not even going to read it because we just aren't going to do it. To better understand the concept of composition, so here I have a set of numbers, and f takes some number here, takes it to an answer. Then what g does is it takes the number that I got here and takes it to a third place. So f goes from here to here, g goes from here to here. What the composition does is it just takes it all the way in one formula. Instead of two formulas to go from here to here and then here to here, the composition just does it in one step. It's one function, it's one formula that takes the place of two. A real-life example here, analogy of composition is airline flights. Let's say f of x represents a flight from New York to Atlanta, and g of x represents the flight from Atlanta to Savannah. F of g of x would represent the direct flight from New York to Savannah. One flight that took the place of two flights. A composite function is one rule or formula that represents the formulas that would have been used in succession. Just like one flight that gives the same result of taking two flights in a row. What we're going to concentrate on composition is finding composition formulas. So finding composition formulas. To explain how we're going to do it, we're actually just write out an example and then we'll do our own. Let f of x equal 2x plus 4, g of x equal x squared minus 2, find f of g of x. First, rewrite it with its nested format. The nested format is much easier to use. Then we're going to start on the inside and replace g of x with its rule, x squared minus 3. So we rewrote it in its nested format. And then all we do is we replace g of x with its formula. Then step 3, next use f's rule of 2x plus 4, but replace the x with x squared minus 3. So the rule is 2. I keep the 2. But I get to the x, I replace the x with whatever's in parentheses, in this case x squared minus 3, and then I keep the 4, plus 4. And then you simplify, and there's my composition. And this will be the end of this video.